Yeah, just going to talk about the testing services that we offer. First off, what are we testing for? We check the initial pH, and then we'll do the acidity titrations, which I'm going to explain a little bit more about right away. And we use a refractometer as well. So the equipment that we need and how does it work? The acidity titrations are easy to run, but it takes time to set up and requires some specialized equipment, which are common in most labs, so particularly a pH meter. That's not only for an initial testing of the pH, but it gives readings throughout the test. The other critical part is our base solution of 0.05 sodium hydroxide. So this is a base solution that is added to the syrup to see how much is needed to alter the pH. So we want to see if a little or a lot of base solution is required to change the pH. So a pH of 6 is critical, as that's the approximate pH of the bee's midgut. So that's going to tell us how much buffering work the bees would have to do to change the syrup. So I'm going to show you a few examples of what we're tested this year. At the top, yeah, you probably can't read these numbers. Don't worry about it. I'll explain it. But at the top, we have a fresh syrup that we got from a supplier. Sucrose syrup typically tests between 6.5 to 7.5 pH. So the first one I have there is 7.4. It was already above 6, and it only needed 0.3 milliliters of this to bring it up into the next pH range. Actually, you know what? I should just backtrack a little bit and tell you about, I think Rob went over this, but just to note that according to Dr. Currie's previous research, if a syrup requires more than 5 milliliters of sodium hydroxide added to reach a pH of 6, then it needed a lot of base solution to alter its acidity levels. And according to Dr. Currie's research, it's not safe. So above 5 milliliters added, it's at a not safe level, especially for winter feed. So between 2 to 5 milliliters added is in a kind of a gray zone, and anything that requires less than 2 milliliters, that would be considered to be safe. So yeah, again, at the very top, a fresh syrup, 7.4 pH, just a 0.6 milliliters added to bump it up to the next pH zone. Did a lab mix, which depending on the water, it can come out lower. So it's 6.5. It needed 0.1 milliliters to bump it up to 7. So just very little, just a drop to bump it into the next pH range. In the blue there, we have a pail I had of syrup and a kind of maybe not the cleanest pail that was left for a few months in a storage facility. Tested at 4.95 pH. I've seen a lot lower, but that's kind of low. And then the acidity titration it needed 3.8 milliliters to bring it up to a pH of 6. So again, that's in the gray zone, 2 to 5. But if we look at a 1-year-old syrup that was stored in a garden shed, it was testing at a reading at 61% on the refractometer, 3.95 initial pH. And to bring it up to 6 pH, it required 11.85 milliliters. So that's a lot more than that 5. We don't want to go past that 5. I think one of the best examples, though, I have here is there was a beekeeper. He held his syrup over for a year. So it was received in the fall, and the leftover was stored outside over the winter. He used it in the spring. Then post-spring, he moved a portion of that into his shop in totes. So I tested that one. It was a pH of 4.3 or 4.4. And the one that was kept inside cool, in a cool-ish area, out of the sun at least, it was tested at 6.4 milliliters to a pH of 6, so just above that 5 threshold, whereas that syrup that he left in his bin over the whole summer, exposed to heat, it tested at 10.5 milliliters to a pH of 6, so a lot higher. So there's a couple of points where we can kind of take actions to extend the life of a syrup. But lastly, I'll mention that at the bottom, there's 2 high fructose corn syrups. One was 4 months old, stored in a tank outside. It was a 4.3 pH, so the high fructose corn syrup, as Dr. Currie mentioned, typically tests between about 3.5 to 4.5 pH. So that's a normal range. it only needed 1.5 milliliters to change the pH range up to 6. It was fine to use. Whereas there was one that I got from a barrel that was sitting outside for about a year, and that needed 20.7 milliliters, so far above the 5 milliliter threshold. So I get there's a lot of common questions about the quality indicators and what we can look at. So Keller, yeah, this may be an indicator, but it's not always necessarily the case. It may look fine, but be degrading. So on the far top right there, we have two syrups. Sucrose syrups. One is absolutely brand new and fine, and the other one is extremely poor. So they look the same in a small sample jar. Again, that's going to be different if it's in a larger tank. That color might show up a bit differently. But if you look at a small amount, that might not necessarily tell you anything about it. It could, but the rate of consumption, as Dr. Currie mentioned, a poor syrup, according to what we saw this fall, was maybe consumed at the same rate or an even faster rate than good quality syrups. So a lot of people say like, well, the bees really sucked it down. I think it was good, but apparently, so what we've seen so far, that may not be the case in terms of an indicator. Again, that may be impacted by any type of additives you may add to your syrup that may impact the process of consumption. For taste and smell, clear signs of fermentation will tip you off, but it's not always apparent, especially when you're using something that, like a Honeybee Healthy or some type of additive that may mask a smell or a taste. With the pH, many beekeepers ask, like, what is the pH, what should it be, and kind of want that to resolve the matters. Like, a pH alone may signal an issue and be a good indicator, but it's the titratable acidity that we use to look at it as a key indicator to tell us if it's safe or potentially unsafe. HMF, so syrups may test within a safe HMF range, but still have other issues. So again, not the only indicator. The sugar concentration, so if you take a refractometer reading and if you're seeing something around 61% from a sucrose, I think it's a good sign to maybe think you should get it tested and send it into the lab if you see some type of degradation going on there. Again, high fructose corn syrup is going to be different because that's 77% typically. Again, frothing. If your syrup is frothing excessively, this is a clear visual sign that there's some type of issue, so it'd be good to get it tested. On that note, just general stuff, avoid holding your syrup over, especially through the summer and in, but if you have to, that's fine. Use clean containers and, try to, if you're holding it over through the summer, maybe try to send it in to me and I can test it. So we charge $15 per sample at the moment. So it's, and I had a form up on the website, but I think it just needs to be updated, and I'm going to get some updated instructions for collecting your syrup. But one thing is, if you're going out there at some point and collecting syrup and then you're leaving it in the honey house for a month or something, that's not a great idea. Just put it in the fridge. It tends to maintain its, what's the word I'm looking for here, but consistency or pretty well. So yeah, hold it over in the fridge or get it to me as soon as possible. What can you do with a syrup that's degrading? In some cases, it's going to be better just to dump it, but in other cases, you may be able to mix it with some fresh syrup and preferably feed it in the spring rather than the fall. So that's all I got, but I think we have a time for some questions for Dr. Currie, and I can answer any questions about testing if you have that as well.
Yeah, just wanted to ask if you're storing in relatively good conditions.
The mic's not going to work.
That's okay.
Okay, I can repeat the question. Go ahead.
If you're storing under reasonably good conditions, will the addition of something like Tylenol help to stabilize it?
The question was, if we're storing it under reasonably good conditions, will the addition of something like Tylenol help to stabilize it?
Yeah, it can, but there are certain additives where it seems to suppress the development of acidity. If you store it at colder temperatures, it tends to suppress it. With high fructose corn syrups, if you tend to add some base to it, there was a study done by USDA that shows that will slow the degradation of that syrup. So the answer is yes, but we don't have really good quantitative data on You know, there's so many different additives out there that I couldn't give you a specific recommendation for a specific product. But having said that, several of the syrups that we received had lemongrass oil or honeybee healthy in them. I forget what yours had in it. Your concoction. None of those worked at suppressing. None of those worked at suppressing the problem with the acidity. So you know. Yep.
In the past, Rob, you would say dilution is the solution, but if somebody has a larger volume of maybe an older syrup, would it be possible for them to send you a sample, and if it is kind of testing in that questionable range, is there anything that you guys could do to kind of indicate whether a dilution could be a...
Yeah, I mean, if there's still good concentration of sugar in there, like you put it in the refractometer, and if it's still above 65%, you can dilute it with other syrup, clean syrup, in the spring and feed it in the spring, but don't feed it in the fall would be my advice.
So if I understand right, the more acidic the syrup, the more unsafe. Can you explain a little bit, if I understand correctly, honey is acidic. Average acidity of honey is about 4.
Yeah, so I can explain that. Bailey actually tested it as well, and old honey will have similar effects. So Bailey tested, I think, 8-year-old honey, and it was as toxic as some of the toxic syrups. pH 4 is in the range of what those high fructose corn syrups are, and if you have a high fructose corn syrup that's 4 but low to treatable acidity, it's suitable to feed in the winter.
I know I missed the first part of the speech because I had run out, but
It was brilliant.
No, the first part of his I read.
Oh, okay. It was also brilliant.
I was just wondering, like, I know you talked on the refractor getting like 61% taste and, you know, smell, but, you know, when you mix something in there, other than sending it in for a test sample to you guys, is there going to be some way we could test it at home a little better before we send the sample in to make sure that it's safe?
Yeah, I mean, I would just go with indicators or time or, you know, how you've stored it. Certainly if you are seeing, you know, a yellow color and you haven't added something to it, then I'd be suspicious. If you have a pH meter and you test something and it comes out, if it's high fructose corn syrup and it becomes below 3.5, I'd be really worried. If it's between 3 and 4, I'd probably say get it tested because it's below what it should be. If you have a sucrose syrup, normally probably the good ones are 6 or above. So if you certainly find something lower than that, it'd be worth getting it tested.
Another question I get sometimes is, if we add something in a brand new syrup, is it going to affect the acidity levels? This summer I only tested one product, Honeybee Healthy, but we did it at different concentrations and we didn't see any impact on the acidity level. I guess a final call for questions and then we'll move on. All right.